Okay, let's go over practice exam number 1, problem number 6. Right, so we have to use the definition of continuity to show that whether or not this function is continuous at x equals 2. Right, so there are three things that we need to check. So first thing is that the limit of f of x as x approaches 2 exists. Right. 2, you have to make sure that f of 2 is defined. Right. Then 3, we have to make sure that limit, which is number 1, is actually equal to number 2. Right. So we have to check those three things. Right. So let's check the first one. Right. So since it's a piecewise defined function, we're going to have to look at one-sided limit separately. So you have a limit as say x approaches 2 from the left. Right. So if you're approaching from the left, you're going to have to look at the first formula. So we look at 3 plus x. So that's going to be equal to, it's just plug in 3 plus 2. It's going to give you 5. Right? If you approach from the right, you're going to have to use the bottom formula, which is x squared plus 1. Right? So which is going to be equal to 2 squared, so 4, plus 1 just gives you 5. Right? So since left hand limit and right hand limit exist, then they give you actually exactly the same value, which means that limit of f of x as x approaches 2 is equal to 5, and obviously this exists. Right, so we check that. Right, then we have to look at the f of 2. So f of 2 is going to be the actual function value when x equals 2. Right, x equals 2 is actually included in the top, so we have to use the top formula. And 3 plus 2 gives you 5. Right, so f of 2 is defined and it's equal to 5. And we know that the both of them gives you 5. So therefore 1 is equal to 2. So limit is equal to the function value. So therefore answer is let's say is a continuous. So yes, f is continuous at x equals 2. All right, that's it. I hope that this was clear.